Hello class, welcome to another video of this chapter. This is, in this video we are going to study third section of chapter 5, section 5.3, and we are finally ready to introduce the basic trigonometric functions. In this section we are going to introduce sine and cosine function and practice them. So far we reviewed circle and angle. Now let's put it together to come up to drive some trig functions. So when you have, so I'm going to use this graph. Look at this graph. You see a circle, radius is r, and you can see the angle theta, which is drawn. As you can see, when you plot an angle, when you draw an angle, that corresponds to a specific point on a circle. So perhaps I draw it myself. Maybe in this way I can better explain it. Look, suppose these are x-axis, y-axis. So this is x-axis and y-axis. And I'm going to put a circle. So the circle is centered at origin. The center is origin. And it has a radius r. Okay, the radius is r. The radius of this circle is r. Now, suppose you you show an angle here. Suppose you show this angle. So you come and draw this angle. And let's say you denote it by theta. Okay, a Greek letter theta. Okay, so every time that you show an angle and draw the angle using a circle, it determines a specific point, a unique point on the circle. Look, this angle, the terminal side, recall that there is for any angle, there is a initial side, which is always ground, x-axis, and then there is a terminal side. So this terminal side intersect the circle at a specific point, right? There is one unique point. So because we are in xy coordinate, this point has some x value and y value, right? So far when we are studying angle, we didn't need any x and y, but actually when you put that circle into this coordinate system, then each angle correspond to one unique point, and that point in this coordinate system has some x value. So it has some x value, right? And it has some y value, right? So now look at this triangle that we already created. So look at this. Here we have a triangle, a right triangle. I'm drawing a right triangle using, so this side is just the x value of this point, and this side is the y value. So maybe I put it here. So look, the value of each side of this. So first of all, this is a right triangle, right? The value of this side is x. The value of the length of this side of the triangle is the same as y value, and the value, the size of this hypotenuse is just r. What is r? R is the radius of this circle. So as you can see, every time that we have an angle, it automatically comes with a right triangle. It indicates, so each angle uniquely determine a unique point on the circle, and also a unique right triangle in which we know the values, we know the size of this triangle. One side is equal to radius, and the other two sides has the same value as the coordinate x value, y value of the point. So there are more into so that's the base of a trigonometric function based on this triangle. So you see, angle theta, any angle, uniquely determines a point, right? A point on the unit circle with coordinate x and y value, and it uniquely determines a right triangle. That's it. With this, we are going to define and introduce a trigonometric function. For example, look at here. You can take the ratio of, I'm going to define the first one. For example, something you can calculate here is the ratio of y over r. So when you have the values of this right triangle, then you can calculate the ratio of the y value, which is gonna be the opposite. So if this is theta, right, this is gonna be the opposite side, and this is gonna be the hypotenuse, right? And that we define that when you calculate that ratio, we name it as sine function, and we say sine of angle theta is equal to this ratio. So what is sine function in fact? Sine function is a function that takes an angle, so the input value is an angle, and it returns you a number. That number is the ratio of y over r, or in another words, let me label them in another way. So this is a right triangle, right? And this is theta. So this is the opposite. This is the opposite side. This is the adjacent side to theta, and this is hypotenuse. I'm sorry, hypotenuse, right? So what we are doing here is actually we are dividing the opposite side 2 over hypotenuse side, right? So it's up to you whether you want to use the y over r or say opposite over hypotenuse. It doesn't matter which way you want to represent it. Anyway, when you have the angle, you have that x, y value, you have the values of those triangle, you can calculate that number. That number, we call it sine of that angle. Similarly, we can calculate another ratio. For example, you can calculate the ratio of x over r. How about this? Because you have it, right? In this right triangle, you have the value of x, you have the value of r, which is the same as dividing the adjacent side over hypotenuse, right? And then we just name it as cosine. We say this is the cosine function, cosine of the angle theta. That's it. We just define the first two basic trig function, sine and cosine. So anytime you just have the circle, if you're given an angle, you can draw the circle, draw the angle, draw the right triangle, calculate these ratios. You have the sine and cosine of that angle. And here is the formal definition. So the sine function, as you can see based on in this picture as well, is the ratio of y over r. So it's y over radius, and cosine is x over radius. Or you can alternatively say sine is the ratio of opposite hypotenuse, and cosine is adjacent over hypotenuse. So let's do one example. Example 1 says the point 3 and 4 is on the circle of radius 5 at some angle theta. Find cosine and sine. Okay, so in this example, we don't know what is the angle, but we have the corresponding coordinate. So we don't know what is the angle, right? But we know that the point 3 and 4 on the circle is at this angle. So I'm gonna, because this is the beginning, I'm gonna draw it. Because if I draw it, then you have a better sense of what is this? What is the radius? Radius 5. So let me first draw a circle of radius 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, roughly I draw a circle. So this is a circle of radius 4. And the point is 3 and 4. Okay, 3. Let me plot the point. The point is 3. So this is 3 and 4. So it's going to be somewhere here. You see? 3 and 4. So that's the point. The point is 3 and 4. Okay, the question says the point 3 and 4 is on the circle of radius 5 at some angle theta. So we know that this corresponds to some angle. So we can draw it. Just connect the origin to this, that's theta. So theta is the angle between the x-axis and the terminal side. Terminal side is this line that passes through our point, okay? So theta is the corresponding angle to the point 3 and 4. Now, what's the question? The question is find cosine and sine of theta, okay? So the question is, what is the sine of theta? Okay, and what is the cosine of theta? So what is sine and cosine? Let's first draw that right triangle, because I told you every time you have an angle and you draw the circle, that creates a unique triangle. Look, this triangle, right? This triangle, this is the right triangle, right? Okay, so I know that when you have this right triangle, sine is defined as, you can go back to the definition. The opposite, y over psi is defined as, so this is y, r, and x. So sine is defined as the ratio of y over radius. So what is y in this case? 4. Radius is 5. That's it. Cosine is defined as the ratio of x over r. X is 3, radius is 5. So even though we don't know the angle, we were able to calculate the sine and cosine of this function. Find cosine and sine of 90. Okay, for 90, this is example 2. Where is 90? Look. So the question is find sine of 90 degree, find cosine of 90 degree. So let's first draw, show 90 degree on x, y, and coordinate. So draw a circle. 90 degree, you start from horizontal axis and you go up to here. That's the 90 degree, right? So this angle corresponds to what point? What is the corresponding point on the circle? The corresponding point is right here. The point, look, if you draw the line, This is the terminal, what is it? Terminal side, right? So you start from ground, you start from x-axis and you rotate clockwise and then you stop here. So that's the terminal side. So terminal side cross the circle at this point. What are the x value and y value of this point? The x value is 0, y value is r, right? Because the circle has a radius of r. So y value is r. What is r in this case? Oh, r can be anything. I mean, it's not given. So I'm just gonna put r, right? Okay, so now, what is sine and cosine again? Sine is y over r. So in this case, y is the same as radius, r, divided by r gives me 1. So sine of 90 is 1. What about cosine? Cosine is x over r. The x, so this is x, this is y. The x is 0 over r, so x is 0. So sine of 90 is 1, cosine of 90 is 0. You can also see that argument here as well. Another thing that we can calculate, this is so easy, is that, so if you have a circle of radius r and you have an angle theta, then we can find the coordinates of the point using the angle, which means that you can, if you're given theta, the angle, then you can find the corresponding x and y. How? Look, you know that sine of theta is y over r, right? The function is defined as sine function is the ratio of y over r, right? So from here you can find y. Y is gonna be r times sine of theta, y coordinate. Cosine is defined as the ratio of x and r. So from here you can solve it for x. X is r cosine of theta. That's it. So once you have, sometimes you are given the angle and the question is find that corresponding x and y value. That's it. From here you can solve it for x and y. And another observation here is that, so you know the when you have a right triangle, so there is an important identity, but I'm going to show you where does this come from. Look, so when you have a circle, sorry, a right triangle, and in this case we have a right triangle, so when you do theta, then you create this, maybe I use a color here, so you create this triangle, right triangle, right? And then if this point is x and y, then this is gonna be x, this is gonna be y, and this is gonna be r, the radius of the circle, right? So we know that because this is a right triangle, we know the relationship between x, y, and r. So we know that x squared, Pythagorean theorem tells us that x squared plus y squared is r squared, remember? From the right, because it's a right triangle, right? So when you have a right triangle, you have this relationship between sides of right triangle. But now we know we can substitute x by r cosine of theta, because we just saw that x is r cosine of theta. So it's going to be r cosine of theta square plus y square. Y is r sine of theta, right? Equal r squared. So I'm using what we saw here, so instead of x and y, I'm substituting the equivalent term using r and theta. R is the radius of circle, theta is the angle. So then you can get a new equation. Look, r squared. So this is gonna be Yeah, this is going to be r square cosine square of theta, r square sine of theta square equal r square. Then you can factor r square, right? So you end up with cosine square sine square equal r square. And then when you divide both sides by r square, you get this identity that cosine square plus sine square is equal 1, which is very, very fundamental trig. This is the first trig identity that you are seeing, and it's very fundamental. It's very useful. We use this all along this textbook and in your following courses. So here is the proof of where does this identity come from, which I also showed you here. Where does it come from? But in reality, what you need to use this equation. So you need to remember it that always the sum of squared of sine and cosine is equal 1. It's called a Pythagorean identity. This is the fundamental trig identity that you need to remember and use. So I'm going to show you one of the application. Let me show you one of the application of this identity. For example, sine is given for some angle. We know the sine. And we know that the angle is in the second quadrant. The question is find the cosine. Look, I'm going to show you how to use that identity to answer this question. So in here, sine is 3/7. And theta is in the second quadrant. Theta in second quadrant. Okay, the question is find cosine of theta. What is cosine of theta? Okay, so in general, if I want to calculate cosine of theta, I need, okay, let me draw it. So I know I have an angle in the second quadrant. This is the first, this is second, third, fourth. So I know it's here. This is the second quadrant. So there is an angle here, somewhere here. I'm gonna draw something randomly, okay? So I know theta is something like this. Okay. And I know the sine, but I don't know the cosine. And I know the relationship between sine and cosine of angle, the trig identity that we just learned. We just learned that the sum of, this is the identity we learned, the sum of sine square, cosine square is 1. So I'm going to use that identity to find this angle. So the identity, the trig identity says that sine square plus cosine square equals 1. And here I know the value for sine. Sine is 3/7. So 3/7 square plus, I don't know the cosine, so I'm just gonna copy that, equal 1. So from here we can solve it for, so this is gonna be, and then we can solve it for cosine. So this is gonna be 40 divided by 49. So cosine of theta is gonna be positive negative square root of 40 divided by 49. You can simplify it, or I don't know. Okay, let me simplify it. You can say 40 divided by 7. You can even simplify it further, but that's okay if you leave it like that. So now I have two values, positive and negative value. Which one should I pick? Pay attention. Which one is the answer? So what is cosine? Let's draw the right triangle here. So here in here, the point, this is theta. It corresponds to this point, right? So this is the point with X and Y value. This is the terminal side. In other words, this is the terminal side, right? So if I'm going to draw a right triangle, that right triangle must be here, because then this is equal to X value and this side is equal to Y value. So this is the right triangle. Do you see that? So theta uniquely correspond to this blue point and to this right triangle. Okay. Okay, so again, what is cosine? The question is, what is the cosine of theta? You see, cosine of theta is x over r, right? X over r. So r is positive, but do you see that the x, this is x-axis, do you see that the x value is on the left side, toward the negative side of the x-axis? So this x value is negative. For that reason, the value of the cosine is going to be negative. So the answer is the negative one, not the positive one. So the cosine of theta in this question, so cosine of theta in this question is negative square root of 40/7. Well, it's not the positive one, not the positive one. Why? Because theta, the question says theta is in the second quadrant. So if you draw it, you see that in the second quadrant, this point, or even forget about the right triangle, this point has a negative x value. And cosine is the x value divided by radius. So because x value is negative, the cosine is the negative number. So the answer is negative. Oh, by the way, 40, they simplified 40. 40 is 4 times 10. A square root of 4 is 2. Yes, you can say it as 2 times the square root of 10/7. But make sure you carry the -1. Why? Because the angle is in the second quadrant. And we know that the x value of the point would be negative. So the cosine value should be negative. So you saw an application of this identity. I didn't know what is theta. I was just given sine. But since we have this identity, we were able to solve it for cosine. Okay, so far we haven't, we just discussed about what is sine and cosine. We saw how to calculate one when the other one is given, but we haven't evaluated sine and cosine for any specific angle. So let's do that. For example, consider angle 45 degree. 45 degree, or in another words, pi/4, and let's calculate sine and cosine of this angle. Okay, I don't know why it takes so long. Okay, maybe I open. Okay, so angle of, so what is the goal? We want to find, so the angle is 45 degree, or in another words, pi/4. And we want to evaluate sine and cosine of pi/4. So we want to find the sine of pi/4 and also cosine of pi/4. That's the goal. What is the sine and cosine of this value? Okay, so let's first draw the angle, put the angle. So this, suppose this is x-axis, y-axis, and then draw a circle, right? And then uh, 45. 45 is exactly in the middle of first quadrant. So 45 is going to be here, right? 45 degree. Or you can say pi over 4. It doesn't matter. 45, or you can express an angle either in terms of degree or in terms of radians. Pi over 4. Okay. So this corresponds to this point, right? It has x and y value. The x is right here. So I think I need more space. Okay, I'm gonna draw a little. Okay. So this is gonna be the x, you see? This is gonna be the x. This is gonna be the y, because it corresponds to some y value, right? So this side of the right triangle, I'm drawing the right triangle. So this side of this right triangle is y, and that's r. And this is also 45 degree. Oh, by the way, your textbook starts with 1. Yeah, you can go with r, or you can draw a unit circle, which means the radius is 1. It doesn't matter. You can have this argument in any circle. Okay, let's do it in a circle with radius 1. Okay, so what is sine? Sine is sine is y divided by r, right? Y divided by radius. In this case, it's y divided by 1. So it's y value. Cosine is x divided by r. In this case, it's x divided by 1. So it's just simply just x value. So in other words, if I have the x value and y value, I just have the sine and cosine. That's it. So now let's just recall our information from geometry. We learned in high school that when you have a right triangle, first of all, the sum of angles are 180. So here we have a triangle. One angle is 90, the other is 45. So this one is also 45 degree, right? And we also learned that when you have a triangle like this, that one of the angle, if you have a right triangle in a way that the other two angles are 45, you see the angles are the same. This one is 45 degree. This one is also 45 degree. Then the sides, the legs of this triangle are also equal. So therefore, x is equal to y. So I just used geometry so far. I recall the information from right triangle. Okay, what else? We also know the identity. Let's use the identity as well. So we know that, or in another words, either the trig identity or the Pythagorean theorem that says x squared plus y squared equal r squared, in this case 1 squared, right? Do you remember? So here you can say, okay, x squared plus, since x and y are the same, so instead of y, I can write it as x, and then solve it for x. So it's going to be 2x squared is 1. So x squared is half. So x is positive, negative, square root of half. But I see that the x value here is positive. You see, 45 degree is in the right, the point is in the first quadrant. So the answer is not the negative one. We accept the positive one. So x is square root of 1 over 2. Or if you rationalize it, it's going to be a square root of 2 over 2. And y is the same thing, because x and y are equal, so y is also square root of 2 over 2. That's it. We calculated the sine and cosine. So sine and cosine, because the y value is square root of, it's square root of 2 over 2, x is square root of 2 over 2. Pay attention that both of them are positive, you see, because they are in the first quadrant, so the x and y value are the same. So that's it. We calculated the sine and cosine of 45 degree. The sine and cosine of the 45 degree are the same value, and both of them are, you can either say a square root of half, or you know, I hope you know, remember rationalization. So you can either say a square root of half, or if you want to represent it in the rational format, you would say 1 over square root of 2 be multiplied by the denominator in order to rationalize it. So the top is going to be this, denominator is going to be this. Okay, so we derived the sine and cosine, or the x and y value of the angle 45 degree. Now find the coordinates of the point on a circle. Okay, so we just got that the coordinate of pi over 4 are, we just found that, right? This is 45 degree. The coordinates are square root of 2 over 2, the x value. And the y value is also square root of 2 over 2. And this is a circle with radius 1. Okay, now the question is, what are the coordinates of 45 degree for a circle of radius 6? Just multiply it by 6. That's it. Just multiply it by 6. Because imagine if you have a bigger circle, I'm going to just put a bigger circle here, right? So suppose you have a bigger circle, but you are still talking about the same angle. You're still talking about 45 degree, right? And then the question is, what are these? The next question is that what are the coordinate of these points? What is the x value, y value of this one? So it's like, look at the x value and y value, it's like they are stretched. And the stretch is the same as the stretch for r. So if, I mean, here we did it with the radius of 1, and in this question says that, what about the circle of radius 6? So if the radius is 6, so which means that if now the radius of the circle is 6 times bigger, so with the same ratio, x value and y value are bigger. So that means we need to make them bigger for 6 times. In other words, just multiply them by 6. Multiply square root of 2 over 2 by 6, multiply square root of 2 over 2 by 6. So you get 3 square root of 2 for both of them. Now let's do 30. Okay, so we showed 45. Now let's find the sine and cosine of 30. So the question is, what is the, for angle 30, so let's alpha to be 30 degree, or in terms of radian, this is gonna be pi over 6. So every time that I'm talking about angle, I give you both the degree version, the degree measurement and radian measurement. Now the question is, what is the sine? And just one more time. Yeah, we are going to evaluate the sine of pi over 6. We want to find the sine and cosine of pi over 6. Okay. I'm gonna draw pi over 6. So let's put x-axis, y-axis. X-axis, y-axis, and a unit circle. What is unit circle? It's a circle centered at 0 and 0, origin, radius 1. So the radius is 1, okay? And the center is the origin. 30 degree. 30 degree is going to be somewhere here, right? 30 degree. And the question is, what is the sine? So if we want to know what is the sine and cosine, that relates to this point, the point on the circle. The corresponding point on the circle has some x and y value. The x value, right, gives me the cosine. Why? Because cosine is x divided by radius. Radius in this case is 1, so it's x. So the x value is the cosine. If I have the x value, I'm done. And the y value is going to give me the sine. So again, I'm going to draw this right triangle. Okay, so the y value is going to be the sine. So if I just have the x and y, I'm done. X is the cosine, y is the sine. Okay, so we need to recall now our knowledge from geometry. Okay, this is the right triangle. And we know that this is 1, right? This is x, this is y. I mean, in terms of triangle. How can we calculate x and y? Okay, so one trick is that if we draw this, if we do this, if we go 30 degree in the opposite direction, so counterclockwise, go 30 degree counterclockwise, okay, and then put this right triangle, okay, so this is 30 degree, oops, this is 30 degree. Then we're going to have a bigger triangle. That bigger triangle is like this, look. Right? Maybe I remove this line to give you an idea of what do I mean. Okay, so the radius is 1. That means this side is 1, this side is 1. This is y and this is y. So this is going to be 2y, right? This side is going to be 2y. This angle 30 plus 30 is 60, right? And by the way, this is also 60 because we know that this is the top part is the right triangle. One angle is 90, the other is 30. So these are also 60. So this is also 60. This is also 60. So we are in a, now recall geometry, okay? So we are having a right triangle. Sorry. We are having a triangle that all the angles are the same. And so if you recall from high school, I guess, in geometry, I think you learned that if you have a triangle that the values, the 3 angles have the same value. So you see all of them are 60. Then the sides have the same value. So this side is 1. This side is 1. So this side also has to be 1. So from here, we can conclude that 2y must be 1. So therefore, y must be half. So that's it. We already calculated 1. 1 down. Look, y is half. So we already have the sine. Now let's find the x. Now we can go back to this triangle to find the x. How? Because we know that, I mean, in this triangle, this one, okay? So in this triangle, we know that x squared plus y squared is equal 1 square, right? Okay, and then we know that x squared plus, we just saw that y is half, right? Y is half. So it's gonna be half a square equal 1 square. So x squared plus 1/4 is 1. So x squared. So just solve it for x. It's gonna be positive, negative, square root of 3/4. Which one should I pick? Should I pick the positive or negative? This point is in the first quadrant, so it has a positive x value, not negative. So I'm gonna keep the positive one and reject the negative one. So the answer is positive. If you want, you can simplify it. A square root of 3, a square root of 4 is 2. That's the answer, positive. So x is positive a square root of 3/2. That's it. So that's it. We derived sine and cosine of 30-degree. With this, drawing, adding another circle, triangle, and recalling what we learned in geometry about triangles, we were able to calculate x and y in this picture, which are in fact the sine and cosine of 30-degree. Okay. So the xy coordinate for the point on the circle with radius 1 for the angle 30-degree, or x is square root of 3/2 and y is half. Okay, I'm not going to repeat exactly the same thing for 60-degree, but you can observe that let me show you why. We just draw here in this, in the left picture, in the left graph, you see the triangle corresponding to the angle of 30, right? So we draw the triangle inside the unit circle with a 30-degree angle. Now reflect it over this line, y equal x, the identity function. We can find we can draw this new triangle, right? So there is an argument if I want to. It requires a little more explanation, but basically we are using symmetry. And then we see that we can see that, or I may be able to explain it to you in another form. Because I don't like that explanation. Let me explain it in my own word. Okay, look. Do you remember I told you that when you have a right triangle, so I'm not drawing the circle anymore, just the right triangle. If this is the theta, then we define the sine of theta to be, in the right triangle, to be the ratio of the opposite side over the hypotenuse side. Do you remember? The opposite side over the hypotenuse side. And we defined cosine to be adjacent, this is adjacent side over hypotenuse side, right? Okay, let's use this in order to find the sine and cosine of 60, because there is a way to derive it from just right triangle. Look, we already calculated 30. In the example, we already did 30. So this is 90, this is 30-degree, and this is gonna be 60-degree, right? Okay, we already calculated the sine of 30 and cosine of 30. We saw that's, you saw the, maybe I don't repeat that here, because you saw that it's half, and you saw that if this is 1, then this is gonna be half, and this is gonna be a square root of 3/2, the value of each side. Look, I'm just putting what we saw here, right? So because you saw that x and y is half, x is the square root of 3/2. So in this triangle, this side is half, this side is the square root of 3 over 2. Okay, so now you want to know what is sine of 60. Look, you want to know what is sine of 60. Okay, just use this definition. It's opposite over hypotenuse, right? So what is the opposite side? Look, what is, if this is 60, what is the opposite side to 60? It's this one. So it's going to be square root of 3 over 2 divided by 1, which is the square root of 3 over 2. What about cosine? Cosine is the adjacent side over hypotenuse. So what is the adjacent for cos 60? This is 60, right? The adjacent leg or side is this one. So it's half divided by 1. So it's 1. You see that? I think this would be easier way to drive the sine and cosine of 60 because we already know what is it for 30. So now pay attention to what we got here. Sine of 30 is half. Cosine of 30 degree is square root of 3 over 2. So do you see that they are, it's like, so do you see that it's like we are switching the, you see, it's like when you have 30 and 60, it's like we are switching the cosine and sine values. It's like switching the x and y values. That's happening, that's what's happening here. So when you have 30 degree, xy value or the cosine sine value is gonna be square root of 3 over 2 and 1 over half. When you have 60, it's just, you switch them. Just switch the value for sine and cosine or x and y. So to summarize what we have seen so far, what we can drive is 0, that for the angles of 0, 30 degree, 45 degree, 60 degree, and 90 degree. And here are the cosines, and the last row shows the sines of each value. You don't have to go through all the work. Look, oftentimes we are going to use sine and cosine of angles. And you don't have to every time to prove it. And I'm not going to ask you to memorize this value. What I would say is that as you do exercises and practice this more and more, after a while, these values sits on your mind. Yes, if you can memorize it, memorize it. But after a while, I hope that on top of your head, you can say, okay, sine of 30 degrees half. Cosine of 30 degree is the square root of 3 over 2. I'm not saying memorize them. I'm saying that by using them over and over, hopefully they stick in your mind. Another point that here worth mentioning is about easy way to derive sine and cosine for some angles, and that's actually related to reference angle. Sometimes it's easy to go back to the reference angle, so you don't have to calculate the sine and cosine every time for each angle. If you know, for example, the sine and cosine for 30 degree, then sometimes you can use that in order to calculate another angle. So that's where the reference angle comes. So what is reference angle? It's an angle. Reference angle is the size of the smallest angle to the horizontal axis. I'm gonna show you an example. And just remember that the reference angle always must be between 0 and 90. And then we can, let me show you an example how you can actually drive the sine and cosine of such examples. For example, find the reference angle of 150 and then use it to find the cosine and sine. So the question asks, basically the question is this. Look, this is the question. You have 150. What is the angle? The angle is 150 degree. The question is find the sine. What is the sine of 150? What is the cosine of 150? That's the question. What to do with questions like that? Okay. So again, I like to show you in a circle because that really is going to help. So let me draw x-axis, y-axis, and a unit circle. Again, what is a unit circle? It's a circle centered at origin, radius 1. Now let's draw 150. So 150, we start from here, we rotate around circle, but we don't touch the x-axis because x-axis is 180, right? So if I subtract 180 minus 150, I get 30 degree. So that means 30 degree, how can I say? So I should stop. And where should I stop? When there is still 30 degree left to reach the x-axis. So I'm going to draw it here. So this is 30 degree. Okay. So when there is 30 degree to reach the x-axis, that's going to be the end point for this angle. So this is 150. Yeah, this is 150 degree. Okay, this is 150 degree. Let me draw the line, the terminal line. The terminal line is going to be this way. Okay. So what is the reference angle? The reference angle here is 30. Again, what is the definition of reference angle? Look at the definition from your textbook. An reference angle is the size of the smallest angle to the horizontal axis. So when you draw 150, what is the smallest angle that it makes to the horizontal axis? It's 30 degree. So it has the 30 degree as the reference angle. And why does that matter? Because I'm going to show you why does that matter. Look, we are looking for sine and cosine of 150. That is the x value and y value of this point, right? Because sine is going to be the y value, cosine is going to be the x value, right? The radius is 1. So that's it. I just need to know the x and y value. But the thing is that if you look carefully, you see when you draw this right triangle, so when you draw this right triangle, in fact, because it has the 30 degree, the angle is 30, I can use 30 in order to do my calculation. So look, maybe I draw something bigger here. So it's like something, a triangle like this, right? Something like this, right? This is 90, this is 30, this is 60, right? And this is the x, this is the y, and this is the 1. And we are wondering what is x and y, because those gonna give me the cosine and sine. Okay, but the thing is that we can calculate that, right? Because we already know that this is gonna be because we know this angle is 30, right? So we know what is y. What is y? Y is gonna be the cosine of 30. I mean, when you just look at, so don't look at the circle, just look at this triangle. In this right triangle, what is y? Y is gonna be sine of 30, right? Sine of 30 degree, which is half. And x is gonna be cosine of 30 degree, which is a square root of 3 over 2. That's it. So using 30 degree, I can, using 30 degree as my reference, I can find the value of x and y. Now, the only tricky part is that pay attention to the sign, because here we are in the second quarter. So x value is negative. So the x value is negative square root of 3 over 2. But the y value is positive, you see. So I can keep the positive half. That's it. You saw it? You saw how did I calculate sine and cosine of 150? I just needed 150 to, I just draw it in order to figure the reference degree. The reference degree is 30. So then I have a right triangle. I can draw a right triangle. One angle is 30. Okay, what do I need? I need the values of those legs, those sides. Okay, because one of the angle is 30. We already learned about 30 degree. We know that sine and cosine of 30 degree. So that's it. I can use it. So that's why I told you, you need to know this table. You need to know this table. So at some point, either keep using it so that it stick your mind, or maybe it would be a good idea if you can memorize it. It would be a good idea to memorize it, because as you can see, to do these problems, we need to go back to the reference angles and use them. So I needed to know that, okay, sine of 30 is half, cosine of 30 is the square root of 2. By knowing that, the rest was just, okay, what about their sign? Is it positive or negative? And that's it. Okay. So we use reference angle to answer questions like this, right? And here you can, in this diagram, you can see so look, you can see the angle in degree, in radians, and its corresponding x and y value. For example, this shows you angle of 90 degree in radian pi over 2, corresponding to x and y value of 0 and 1. Just recall that x is the cosine and 1 is the sine. So these x and y value are also the cosine and sine of the theta. Recall that when you do unit circle, the x value is the cosine, the y value is the sine. So for example, look at here, 0 and 0, 1 and 0. So what does it mean? It says that for the 0 degree, x is 1. So that means cosine of 0 is 1. Y is 0, so sine of 0 is 0. So, okay, let's look at example 6. It says find the coordinate of the point on the circle of radius 12 at this angle, 7 pi over 6. So the fact that the radius is not 1 and it's 12 is just whatever is the sine and cosine of 7 pi over 6, just multiply it by 12. That's about it. So the only thing we just need to know is we need to find the sine and cosine of 7 pi over 6. So let's practice this one. Example 6, I guess, right? Yes, 7 pi over 6. So the angle here is the angle is 7 pi over 6. Let's first see where is this. So x-axis, y-axis, unit circle. Unit circle is a circle center at 0, radius 1. Okay, 7 pi over 6. So I know it's gonna be, look, 7 pi over 6 is like 6 pi over 6 plus, 7 is 6 plus 1, right? 1 pi over 6. So this is gonna be pi. So it's like pi plus pi over 6. Okay, so it's gonna be pi. Okay, so I need to start and come to here. This is pi, and then move further. How much? 4 pi over 6. So I will need to go for pi over 6 as well. Okay. And then this is gonna be the angle. Okay. So what is this angle? The whole angle, right, is this is 7 pi over 6. How did I draw that? Look, I first came as 1 pi. This is pi. Oh my God. I'm sorry. I have to open another one. Okay. So I don't know what's wrong with my whiteboard. Okay, so we are doing example 6, and I should show you one more time how to get to 7 pi over 6. This is x-axis, y-axis, unit circle. So 7 pi over 6. So look, if you rotate around the unit circle up to here, that's pi, right? And if you go further, for how much? For pi over 6, then that's going to give you 7 pi over 6. So pi plus pi over 6 is going to give you the 7 pi over 6. So my point is that this portion here is just pi over 6, this part. And this part is pi. So in total, this is going to be 7 pi over 6. And it's going to correspond to this point, okay, with some x and y value on the circle, this point on the circle. Okay, what was the question? The question was find the coordinates of the point on the circle of radius 12 and this angle. So if I just find these coordinates, this coordinate x, y coordinates of 7 pi over 6, then because radius is 12, I just multiply it by 12. So that's the only thing I need. I need to find this x and y. So this x is right here, look, it's this x value. And y is this y value, right? Okay, so technically I can use pi over 6. The reference angle is pi over 6. You see that? So for 7 pi over 6, the reference angle is pi over 6. It's the smallest degree to the horizontal axis. So I can use that. So let's see. So we have a right triangle here, right? And I'm going to draw it here because I need a bigger, perhaps a bigger picture, bigger triangle. Look, the question is, if this is the horizontal axis, this is pi over 6, and this is pi, right? This is pi over 6, this is x, this is y, and this is 1. Okay, what is x and y? So we know that we know the sine and cosine of pi over 6. Sine of pi over 6 is half. Cosine of pi over 6 is a square root of 3 over 2, which is sine is the opposite to the adjacent. So that's the y, and cosine is the adjacent. So it's x. Okay, so I got the value for x and y. Okay, but what about the sine? So x value is a square root of 3 over 2. Y value is half, right? What about their sine? Look, so x is negative. I can see because it's in the third quarter. So x is negative, y is also negative. You see that? So both of them are negative, right? And this is for unit circle, but because in this circle we have the radius of 12, just multiply it because of the stretch, just multiply it by 12. So multiply them by 12. So it's gonna be negative 6 square root of 3 and negative 6. That's it. So as you can see, the x coordinate and y coordinate is the 12 times just sine and cosine of the reference angle, which is you saw it, it was pi over 6. And here we have the coordinate of this angle. So I think that's enough for our practice, and now you should be able to do the exercises of this section. Thank you for watching this video. I'll see you next time.